Hello, my name is Miss Garza, and I'm going to present to you today on how to calculate the atomic number and the mass number when you're given information about a proton, an atom, protons, electrons, and neutrons. So let's go ahead and get started. So let's first define what is an atomic number. By definition, the atomic number is the number of protons in an atom. And so if you look at this model in the presentation, there are three red protons in the nucleus. So we can infer from the definition that the atomic number of this model is 3 because they have 3 protons. Neutral atoms are electrically neutral. So what does that mean? Well, that means that neutral atoms have an equal number of positive particles and negative particles. So since atoms have positive protons and their electrons are negative, in a neutral atom, both will be equal. So in this atom in the presentation example, if we have 3 protons, you can see 3 red protons, and then you will see 3 yellow electrons orbiting around the nucleus. Then we can determine from the picture that the atom is neutral. Another example that I've given you on the slide is oxygen. Oxygen has an atomic number of 8, which we can get that information from a periodic table. So it has 8 protons and 8 electrons. So in summary, we can say that the atomic number equals to the number of protons and the number of electrons. Now we're going to remember all this information. Well, we have a useful acronym called APE. We can use APE. A for atomic number will equal to P, which is number of protons, will equal to E, the number of electrons. Mass number. If you recall, mass of an atom, majority of the mass of an atom is found in the nucleus. But that's because the heaviest subatomic particles of an atom are found in the nucleus. That's proton and neutron. Electrons are so tiny that they're essentially zero for mass. So we don't count them. So for mass number, because the heaviest particles are your protons and neutrons, well, the mass number is equal to your number of protons and neutrons found in the nucleus of an atom. So we add those two numbers together. So if you know the mass number and if you know the atomic number, then you can calculate the number of neutrons in an atom of a particular element. Let's look at this example on the presentation. You can see that there are 4 green neutrons and 3 red protons. So adding those two numbers, 4 plus 3, then the mass number of this example is equal to 7. So here on this slide, you'll have 2 ways to determine a different type of information. If we want to know the mass number of an element, then we just add up proton and neutron. If you want to know the number of neutrons, then we need to adjust the formula a little bit. And that would be subtracting the mass number and or subtracting the number of protons from the mass number. So neutrons is equal to the mass number minus proton. So let's do this example. The lithium atom, which you see as an example here as a model, has a mass number of 7 and the atomic number of 3. So how many neutrons does it have? Well, mass number minus atomic number, which is your number of protons, equal to neutron. So 7 from the problem for mass number, minus the atomic number, which you get from the problem, is 3. So 7 minus 3 is equal to 4. So lithium have 4 neutrons. Or you can look at the picture and you can count 4 green neutrons. So let's see how we can use this information in working on a handout.